Hello everyone, and welcome to this new tutorial. In this video, we will see how to visualize QTAIM results generated by TopChem2 from its output files, including the positions of critical points, bond paths, and topological features of the molecular electron density. The first step is to load a new structure, typically generated by TopChem2. We can now load the descriptor XYZ file created by TopChem2. This file contains the positions of all critical points and useful information from the local topological analysis. In this tutorial, the selected example is the planar orthonitrophenol molecule. We first see the positions of the atoms, together with the critical points displayed as three-dimensional crosses. Using the sliders, we can change several parameters, such as the opacity of the atoms and the atomic radii. As well as the display of the critical points. We can also change the molecular representation, for example CPK or wireframe, and display. The molecular axes. Atom labels and atom numbers can be displayed, and the same option is also available for the critical point labels. Here, we can see different types of critical points, for example the 3-1 and 3+1 critical points in this molecule. For a clearer visualization, we can remove the labels. By default, the hydrogen bond display mode is active. This mode can also be hidden. Now, let us open the menu used to measure distances and angles. By simply clicking on two critical points, or on two atoms, we can highlight the selected pair. And measure a distance or an angle. In this example, the selected atoms define a plane. We can now clear the distances and angles, and then disable the measure menu. Now, let us look at the animation mode. This mode is available directly in the viewer. It can also be used to export an animation. Two interaction modes are available to manipulate the molecule. The default mode is rotation, but a translation mode can also be selected. For a better view, we can hide the control panel and switch to a larger display. Now, we can visualize an isosurface of the electron density. First, we load a standard cube file. A compressed QBES file is also supported. By TopChem2 calculations. This compressed QBES format is available in TopChem2. Select the ISO value of the surface using the slider. You can also adjust the opacity of the surface. Perfect. Several parameters can be changed for the surface. For example, we can modify the rendering style. Or the color of the isosurface. Other parameters can also be adjusted, such as the material. Used for the surface rendering. Now, we can display a two-dimensional map and add ISO value contours. First, we need to load a cube file containing the electron density. After that, you can select the plane and move it using the Shift key on your keyboard. You can then modify several parameters, such as the line thickness and the color. Or the line spacing. OK. We can now observe the ISO values of the electron density. We can adjust these parameters interactively, and we can also select the auto-scan mode. To animate the two-dimensional map. This creates an animation of the selected planes.